All right, so let's bring torque into the real world. As I said before, the body is basically just a big cloud of torques. You have all these forces, all these muscles, all these tendons acting around all these joints, and so these joints act as like little axes of rotation. All right, and analyzing that is important for keeping the body in good health and minimizing the amount of stress that you put on the body through different activities. And so in this problem, this one called bodily torques on this slide, it says torques are constantly being applied to the body with their joints as points of rotation. In the picture below, the patient's lower leg weighs 4.1 kilograms and the load or the weight over here. Oh, these are backwards. Would you check this out? This is going to be the leg and this is going to be the mass, right? So you have the weight of this mass over here that's attached to this person's leg. They're like doing a little workout like this to make the hamstrings all powerful. And then there's also the weight of the leg. Okay, so the question is asking, how do we find the net torque around the knee? Okay, what is the net torque on this leg using the knee as the axis of rotation? All right, well, as we learned, torque is equal to R, the distance away from the axis of rotation, times the forces that are applied times sine theta, right? So the net torque would just be the sum of all the torques. Make sense? So when you're finding torques, basically for every force, there's one torque. So you know you have a torque around, a certain axis if you see a force. So if there's two forces acting on this leg, that implies to us that, there must be two torques, right? The second thing we need to know is how far are those forces away from the axis of rotation? So in the case of the mass that's attached to this person's leg, right, I make this distance here. I don't say it in the problem, but it's, we'll take the approximate of, a typical, lower leg for a person is about 0.5 meters, let's say, is a good approximation. Okay, so that's my R for the weight of this mass here, right? But what about this R, right? How far is that? Well, this is the weight of the leg. And remember, the weight of the leg acts at the center of mass of the leg, which we can say is approximately the middle of the leg. So I can just say that that's 0.25 meters. Okay, so now I've set myself up to do a very, very simple net torque to find all the torque around this knee. Okay, so first things first, let's start with the mass, right? The weight of this mass, the torque of this mass. So I can really say that that torque net is going to be equal to the torque due to the mass plus the torque due to the leg. Okay, now the torque of the mass, first thing we got to ask ourselves, is it a positive or negative torque? And we look at which direction this mass wants this leg to rotate. Well, it wants it to rotate this way, right? Which is, clockwise, right? It wants it to rotate clockwise. That means that is going to be negative, so we can put a nice negative sign in front, okay? How far away is it? Well, it's 0.5 away from the axis of rotation, so I can put a 0.5 there. All right. What is the force? Well, it's the weight of this mass. The mass is 3.3 kilograms, but that's not in newtons. How do we get from kilograms to newtons? How do we get from mass to a force? We multiply by gravity. So this would be 3.3 times 9.8, right? And notice, here is the axis of rotation, and the force is going straight down. So what angle is that? 90 degrees. So there'd be a sine of 90 there, but we don't even have to put that because sine of 90 we know is 1. So this is 1 for this case. Okay? All right. We have our first torque. What about the second guy? Well, again, what's the direction? It's pointing down. If this is our axis of rotation, this leg will want to rotate this way, right? okay? In other words, clockwise. In other words, this will be negative again, right? And if this is halfway, right, you know, because it's acting at the center of mass, then the R is going to be 0.25. The mass is 4.1. And the gravity, again, turning the mass into gravity, is 9.8. Just in case we're off the edge, I'm going to put that underneath. So 4.1 times 9.8. And so my net torque about that knee joint experienced by this person with the weight on them is going to be these two things summed, a negative and a negative summed, for a grand total of, I get negative 26.2. And torque doesn't have any special units. It's just a Newton meter, which makes sense because here's a meter and here's a Newton. Okay? So we now know the net torque around this person's knee. You've taken your first step to understand how forces operate on the body in terms of torque, okay, to create torques. So part B says, what is the direction of that torque? Negative, right? In other words, remember, we do R cross F, which means the torque would be coming out at you guys, so pointing in that way, right? R, that's the radius, cross F, the force, both those forces, and it's going to be into the board. So the torque faces that way, okay? And what would be the new torque after the patient rotated their lower leg 45 degrees down? So now instead, the leg is like this. Right? And you still are going to have a weight due to the mass, and then you're still going to have a weight due to the leg, right? Except now the sine is going to be 45 degrees for both of these. So you solve the problem the exact same way, except this guy now gets a sine of 45. This guy here gets a sine of 45. And so instead of 26.2, I get 18.5. And I recommend all of you guys double check me on that, multiply that by sine of 45, that by sine of 45. Remember, this angle, this degree, this theta, is always between the axis, or I guess the line created by the actual object pointing away from the axis of rotation. Okay? So for any object, right, the angle is between the force and that line coming from the axis of rotation. Okay, so we've done it. We've found how torques operate in the body. We also found that simply by changing this angle, okay, we now have the sine of 45. We have less torque at that 45 degree angle acting on that joint. Pretty cool. So we've already got a sense of how just changing the configuration, changing the angle that your leg's at, provides a little bit less stress on the body.